Chapter 4 on Dynamic Routing Protocol, Part 2. Okay, Part 1 is already covered in Chapter 3. Okay, quick recap on the purpose of Dynamic Routing Protocol. Firstly, is to discover the remote networks. That is, those networks that is not directly connected to the router. Secondly, the Dynamic Routing Protocol will enable the routers to talk to each other, send route advertisement to each other, so that the routers can maintain up-to-date routing information. And with this information, the router is able to calculate the best path to the destination network. Okay, so Dynamic Routing Protocol will contain algorithms to help the router to calculate the best path. And if the best path is no longer available, maybe due to the link goes down, module goes down, it's the role of the routing protocol to find the next best path if the current path is no longer available. Okay, there are basically two types of routing protocols. One is the Interior Gateway Protocol. It's used to route within an autonomous system that is within a same organization, the same campus, the same company. So example are RIP, EIGRP, OSPF, IIS. The second type is the Exterior Gateway Protocol, the EGP. It's normally used for routing between the different autonomous systems. Okay, example of EGP is BGP. Okay, exterior routing protocol are normally used by the ISP for routing between the different organizations at the ISP backbone. In our module, we will basically focus on the IGP. Okay, for IGP, there are basically two types of routing protocol. The first type is called the Distant Vector Routing Protocol. The second type is called the Link State Routing Protocol, which we will discuss later. Okay, first, Distant Vector Routing Protocol. Okay, basically, distant vector means that the routes to the remote network are advertised by using two characteristics. Number one, distant. That means how far is the destination. Okay, normally we'll use hop count as by RIP. Okay, and EIGRP will also use things like bandwidth, delay to calculate how far is the destination network. Okay, the second is the vector. That means the direction. Okay, how to route the packet to the destination network. So to the router, the direction will be the exit interface or the next hop IP of the next router. Okay, to send the packet to. So distant vector routing protocol have these two characteristics: distant and vector. Okay, example of distant vector routing protocol are RIP version 1, which have been obsoleted, okay, mostly replaced by RIP version 2, IGRP, and the Cisco EIGRP. Okay, Link State Routing Protocol works very differently from Distant Vector Routing Protocol. Okay, for Link State Routing Protocol, a link state router uses link state information received from the other routers. Okay, using this information, they will create the entire topology map. And with the map, they can select the best path to the destination network. One of the characteristics of the link state routing protocol is they do not use periodic updates. That means the router do not send update on a periodic basis. The update are only sent when there's a change in the topology. Okay, example of link state routing protocol are OSPF and IIS. Okay, another way to classify routing protocol is classful or classless. Classless routing protocol will include the subnet mask information in the routing update, as compared to classful routing protocol will not send a subnet mask. Okay, if you remember, when the IP version 4 network was first invented, all IPv4 networks are classful network, meaning they are either class A, B, or C, and they have a fixed subnet mask, either 255.0.0.0 for class A, class B will be 255.255.0.0, class C will be 255.255.255.0. Okay, but we realize that this is very rigid, so we have moved to classless routing protocol or VLSM, variable length subnet mask, where the subnet mask do not need to be fixed. It can have variable lengths. So with VRSM, we also introduced something called the classless inter-domain routing, which allow routing inside a classless network. Okay. So classless routing protocol will obviously work if your network is classless. Okay. If your network is classless and you use class-through routing protocol, it may work, but it may also create problem when you have a discontinuous network. Okay, if you look at this example, okay, in this case, we have the 172.16, which is a class B network. Okay, on the left. On the right, we also have another 172.16, which is also a class B network. Okay, if you run class-through routing protocol here, it may cause some problem because to R2, he received an advertisement saying the 172.16.0.0/16 is located in this direction. Okay, over here. Okay, he received the advertisement, okay, from R1 about this network exists. He also received the advertisement from R3. Okay, saying that the 172.16. Okay, sorry, this is .16. Okay, so again here R3 advertised to R2 saying that the 172.16.0.0/16 network is located on R3. Okay, because we are running class-through routing protocol, okay, then the class-through network will be summarized at the boundary, at the class-through boundary. So from 172 to 168, it will be summarized to a /16 network. Same here, this will be summarized. So R2 received two advertisements regarding 172.16. So which one will he choose? He will choose the one with the least cost. Okay, either R1 or R3. He will choose one of them, either via R1 or via R3. Let's say he choose R1 because, for example, R1 have a lower cost. He will not choose R3. So this network will be unreachable. Okay, this network will be unreachable. Okay, so this may cause routing problem if your network is disjoint and if you are running class-through routing protocol in your classless network. Okay. So we have seen that in lab 3, when we run lab 3 last week, when we run auto summary. Okay, classless routing protocol like RIP version 2, EIGRP, OSPF, IIS will all include subnet mask in their routing updates. Because they are classless, they support VRSM and CIDR, the classless inter-domain routing. Okay, and for IP version 6, everything is classless. We do not have any more classful system. Okay, let's compare the different routing protocol. Okay, first, distant vector routing protocol. Okay, they are RIP, both version 1 and version 2, IGRP, which also have been obsoleted and be replaced by EIGRP. Okay. For link state routing protocol, we have OSPF and ISIS. Okay, mainly we will look at OSPF. Okay, we'll look at the speed of conversion. Okay, RIP and the distant vector routing protocol, like RIP, IGRP, EIGRP. Okay, normally it will be slower as compared to the link state. Link state routing protocol, normally it can converge much faster as compared to the distant vector. Okay, but as I said, for EIGRP, we also have to converge fast. But link state generally will convert faster than distant vector routing protocol. And distant vector routing protocol normally is used for smaller network. Link state routing protocol used for larger network. Again, EIGRP is a bit exception. It can also use for large network. As for use of VRSM, it depends on whether is it classful or classless. Okay, classful routing protocol are RIP version 1, IGRP, so they don't support VRSM. Okay, RIP version 2, EIGRP, OSPF, IIS, they are all classless routing protocol, so they support VRSM. Okay, resource usage. Link state routing protocol tends to use more resources like CPU, computation, so memory usage. They normally use higher, so they require a high resource utilization on the router. Distant vector tends to use lower. Okay, EIGRP is somewhere in the middle. Okay, and finally, how do you, the implementation, the knowledge on how the routing protocol works, how do you maintain the routing protocol? Distant vector tends to be easier to understand. Okay, EIGRP, because they use a number of parameters to calculate the shortest path, so it can also be quite complex to understand. We'll look at distant EIGRP in the later chapter of the next term. Okay, for link state routing protocol, they are all complex. Okay, because the way they calculate the cost is also quite different. So they will take up more resources, and it will be a bit more difficult for you to understand OSPF and IIS. Okay, again, we will only focus on OSPF. Again, we will do that in the later chapter. Next, okay, we'll look at the term called metrics. Okay, metrics is used in all routing protocol. Okay, what is this metrics? Okay, metrics is also known as cost. Okay, you should be aware that cost, the higher the cost, the worse it is. Okay, the not so desirable. Okay, it's like we want to buy something from the market or from online, you always look at the cost. The higher the cost means the less desirable. You want to buy things that are of a lower cost. So same thing with path, or the best or calculation of path from a source to the destination. The lower the cost, the better is the path. So remember, cost lower, better. Okay, so because cost and metrics are used the same, so metrics also, the lower the metrics, the better it is. Okay, so cost and metrics refers to the same things, but it's sometimes easier to refer it as a cost. Okay, so metric is a measurable value. Okay, it is used to determine the cost of a path from the source to the destination. So the best path is the one with the lowest cost. Okay, how do they calculate? What kind of metrics do they use? Okay, it depends on the routing protocol. For read, it's purely based on hop count, how many routers away. They use that to calculate the metrics. So obviously, the lower the cost, meaning the nearer the less hop it is, the better is the route. OSPF uses bandwidth, cumulative bandwidth. Okay, that means the bandwidth across the same path from one router to another router. They will add up the bandwidth between the routers, okay, to calculate the cost. For EIGRP, it's more complicated. They use more things to calculate the cost: bandwidth, delay, load, and reliability. Okay, so just to compare between RIP and OSPF, RIP choose the best path based on how many hops away. OSPF choose the best path based on bandwidth.